So we need to identify the transformation and verify that it is a congruent transformation. So we have a triangle, X, Z, Y, and the vertices are at, so we have X, and this is at 2 minus 8. We have Z, which is at 6 minus 7, and we have Y, which is at 4 minus 2. And then we have a second triangle, which is triangle ABC. And this has vertices. So vertices are at A is 2, 8. B is 6, 7. And C is at 4, 2. Now, we've graphed the figure. So we've got the graph here. And we need to confirm what type of transformation this is. So if we look here, we can see this is the x-axis, and this here has been reflected onto ABC. So this is a reflection, but we need to confirm by using the distance formula. So we're going to have a look at that. So first thing we need to do, so we're going to use the distance formula. To verify the points are congruent. So we're looking for the same distance. So the distance formula, this is the square root of the difference between the x values squared and the difference between the y values squared. So we need to put into our formula our values. So the A, we call this x2, and this will be our z2 and our y2, and this will be our x1, our z1 and our y1. So we're going to use the two values at each time. So we'll start off comparing. So we'll use AB. So we're going to look at AB first. So this here we can say the distance, and we'll substitute in 6 minus 2 and is squared, 7 minus 8 squared, and this will be, if we put it in our calculator, so we've got the 16 plus 1, so the square root of 17. So that is the difference, distance from A to B. So we'll say the distance. And now we need to look at a point. So AB is here. And we want to see if this is congruent with XZ. So we need to check XZ next. So XZ, and we're going to put the values in. So we're going to have 6 minus 2 squared plus minus 7 minus 8 squared. So we'll have 4 squared minus, so it's going to be plus minus 7 plus 8 squared, which will be at the square root of 16 plus 1, which is root 17. So the distance between XZ and AB are equal. So at the moment, these two are the same. So now we need to go to the next point. So another point that we have, so we can see that BC and and YZ. So we'll compare those. So BC, this is the 6 minus 4 squared plus 7 minus 2 squared. And if we put, so you've got 6 minus 2, so that's 2 squared, plus 5 minus 2 is 5, plus 5 squared. So that's 4 plus 25, so that's root 29. And then if we look at ZY, so this is 6 minus 4 squared, plus minus 7, minus 8 squared. So if we look at this, this is 6 minus 2 squared, which is 4. And then we have minus 7 plus 8 squared. So 1. So that will be okay, just corrected this. So it's minus 7 minus 2. And okay, so that's minus 7 minus minus 2, which is plus 2. So that's 5, which is 25. And there, so that is 29. So those are equal as well. So we're going to look back now, and we need to look now at AC and XY. So we're going to check if they are the same. So the distance formula, so we've got AC and XY. So AC and the distance formula, so we've got 4 minus 2 squared plus 2 minus 8 squared, and that will be root 40. And we need to look at XY. So XY, so looking at the coordinates, we have the difference in the x's is 2 minus 4 squared. And then the y coordinates, so we have minus 8 minus minus 2 squared. And if we work that out, that is also, they are equal. So we can say since AB is equal to XZ and BC is equal to ZY and AC is equal to XY, AB is congruent to XZ, so we can say the line, and the line BC is congruent to ZY, and AC is congruent to XY. And this is by side, side, side that we've proved that triangle ABC is congruent to triangle X, Y, Z.